Hello everyone. In this video we are going to solve the problem number 1.21 from Irodov, and that is related to kinematics. So let us first read out the problem and then we will solve the problem step by step. At the moment t is equal to 0, a particle leaves the origin and moves in the positive direction of the x-axis. So let us say this is the point at which particle is there at the instant of t is equal to 0. It is at the position of x is equal to 0 and it is moving in this direction, which is the positive x direction. Okay, and the expression of the velocity is given as v is equal to v naught, times 1 minus t upon tau, and v naught is the initial velocity vector whose modulus is equal to 10 centimeter per second and tau is equal to 5 seconds. So v naught is given as 10 centimeter per second and tau is given as 5 seconds. And it is also said that v naught is the initial velocity vector, so we can represent it as v naught times I cap, because at t is equal to 0 the particle is moving in the x direction. So v naught vector we can write it as 10 I cap. Okay, so the velocity vector we can write 10 times 1 minus t divided by 5 times I cap. So this is the velocity vector we are having. Okay, now in the first problem it is asked to find the x coordinate of the particle at the time moment of t is equal to 6 seconds, 10 seconds and 20 seconds. So let us say the particle is at the point x is equal to 0 at the time moment of t is equal to 0, and it has displaced by the displacement of, let us say, delta s, and it has reached to the position of x. Okay, so at the time moment of t is equal to t, so the displacement delta s we can write it as the final position minus initial position. Final position is x minus initial position is 0. So the delta s is equivalent to the position at the time instant of t. How to find the displacement? That we can find it by integrating the velocity. So we can write velocity into dt, integral from time instant of t is equal to 0 to time instant of t is equal to t. Velocity is given as 10 times 1 minus t by tau into dt integral t is equal to 0 to t is equal to t, and tau is given as 5 seconds. As 10 is constant, we can take it outside of the integral from t is equal to 0 to t is equal to t, 1 minus t by 5 into dt. If we integrate 1, the integration of 1 is t, minus integration of t is t square by 2. So we will get t minus t square by 2 from time instant of 0 to time instant of t. So finally the value of the displacement we will get 10 times t minus t square by 10, and this is also equal to the position at the time instant of t. Okay, now in the problem it is asking for the position at different time instant, so we can write here t in second at the time instant of 6 seconds, 10 seconds and 20 seconds. Position in centimeter we can write it as 10 times 6 minus 6 square by 10, that is equal to 24 centimeter, and here we can write 10 times 10 minus 10 square by 10, that is equal to 0 centimeter, and here we can write 10 times 20 minus 20 square by 10, that is equal to minus 200 centimeter. So what is happening here? Let us say initially the particle was at x is equal to 0 and it is moving in the positive x direction. If we carefully look at the velocity vector, then velocity vector is given as 10 times 1 minus t divided by 5 is equal to into I cap. So we can see that the velocity vector is 0 at the time instant of t is equal to 5, and after that it will move in the negative x direction. So it will go till here, till the time instant of t is equal to 5, and after that it will move in the negative x direction. At the time instant of t is equal to 6 seconds, it will be at the position of x is equal to 24 centimeter, and at the time instant of t is equal to 10 seconds, it will reach to its initial position, and then at the time instant of t is equal to 20 seconds, it will reach at the position of minus 200 centimeter. Now coming to the second part of the problem, in the second part it is asking the moments of the time when the particle is at the distance 10 centimeter from the origin. Okay, so if the particle is at the 10 centimeter from the origin, that means it can be at the position of x is equal to plus 10 centimeter or at the position of minus 10 centimeter. Okay, then only it will be 10 centimeter in both the cases. Okay, so we are having the expression of the position that we have found out here, and this we will equate it to plus minus 10. So 10 times t minus t square by 10, that we can equate it to plus minus 10. So from here we will get 10t minus t square is equal to plus minus 10. Then we can write here t square minus 10t plus minus 10 is equal to 0. So here we are having two quadratic equation. One quadratic equation is t square minus 10t plus 10 is equal to 0, and another quadratic equation is t square minus 10t minus 10 is equal to 0. If we solve the value of t from here, we can write t is equal to minus b plus minus b square minus 4ac under root divided by 2a. Okay, so from here we will get 10 plus minus 60 under root divided by 2. So we will get 5 plus minus root 15. This is the value of t we will get, and from this quadratic equation we will get t is equal to 10 plus minus 10 square plus 40 under root divided by 2. From here we will get t is equal to 10 plus minus 140 under root by 2. So we will get t is equal to 5 plus minus root 35. And if we carefully look at here, the value 5 minus root 35, it is the negative quantity, and time cannot be negative. So we will reject this particular value. Now we are having three values of time, that is t is equal to 5 plus root 15, 5 minus root 15 and 5 plus root 35. So these are the time instant at which the particle will be either at the position of x is equal to plus 10 centimeter or x is equal to minus 10 centimeter, or we can say that it is at a distance of 10 centimeter from the origin. Let us come to the C part. In the C part, it is asked to find the distance covered by the particle during the first 4 and 8 seconds, and also to draw the approximate plot st, that is as a function of time. Now in order to find the distance, we have to know what is the value of speed, because distance s we can write it as integration of speed from t is equal to 0 to t is equal to t. Now speed we can write it as the magnitude of the velocity, that is equal to 10 times 1 minus t divided by 5 magnitude. Now if we look at this particular expression, this expression is 0 at t is equal to 5. This is positive when time is less than 5 seconds, and this is negative for the time greater than 5 seconds. Okay, so if we look at the function such as mod x, that is equal to x for x greater than 0 when it is positive, and when it is negative we can write it as x for x less than 0. Similarly, for the speed we can write it as 10 times 1 minus t divided by 5 for t less than equal to 5, and 10 times t by 5 minus 1, which is the negative of this particular expression. So for that we can get t greater than 5. Okay, so this is the expression of velocity we got. Now in the problem it is asked to find out the distance till time t is equal to 4 seconds. So for that we can use the first expression, because here the time is equal to 4 is lying in the region of t less than equal to 5. So again we can find the distance is equal to speed into dt, integral from t is equal to 0 to t is equal to 4 seconds. So if we integrate this particular expression, we will get t 10 times 1 minus t by 5 into dt, integral t is equal to 0 to t is equal to 4 seconds. So from here we will get t minus t square by 10 from t is equal to 0 to t is equal to 4. And if we solve this particular expression, we will get 24 centimeter. Now the next part is saying to find the distance till t is equal to 8 seconds. For that we can write distance is equal to speed into dt, integral from t is equal to 0 to t is equal to 8 seconds. Now we have to divide this speed into two parts, because the expression of speed is different in different region of time. So we can write it as 10 times 1 minus t by 5 into dt, integral from t is equal to 0 to t is equal to 5, plus 10 times t by 5 minus 1 into dt, integral t is equal to 5 to t is equal to 8 seconds. So if we solve this particular expression, we will get 10 times t minus t square by 10 from t is equal to 0 to t is equal to 5, plus 10 times t square by 10 minus t from t is equal to 5 to t is equal to 8. And if you solve this, we will get 34 centimeter as the distance in the time duration of 8 seconds. Now it is asked to find the plot for st, which is as a function of time. Now we know that till t is equal to 5 seconds, the distance and the displacement will be the same. So let us say for t less than 5 seconds, we can write st as the expression of the position or the displacement, that is equal to how much? That is equal to, we have found out here, that is equal to 10 times t minus t square by 10. Okay, so we can write it as 10 times t minus t square by 10. Okay, if we carefully look at here, this is a parabola 10t 1 minus t by 10, whose roots are nothing but t is equal to 0 and t is equal to 10 seconds. Okay, so if we draw the parabola here, let us say this is the time and this is the distance as a function of time, and it is having the two roots, t is equal to 0 and t is equal to 10 seconds, and it is downward parabola because here we are having the negative. So the parabola will look like this for entire 10 seconds, but we want our function for only 5 seconds because we are drawing the expression only for 5 seconds. So 5 seconds will be till here. So we can remove this particular part, so the distance will be like this. And the next expression for the display distance, we are having it as st is equal to 10 times t square by 10 minus t. Okay, and for this particular expression we know the roots, again t is equal to 0 and t is equal to 10, but it is upward parabola, so the parabola will look like this. But we have to find the distance. For that we have to add this particular part in this expression, in this particular expression. So we will get the distance like this. So till t is equal to 8 seconds, it will be like this. So this part of the expression. So this is the graph we have got for the distance versus time. I hope the entire procedure is clear. Thank you.